So I've been invited here today to present the construction, redevelopment, and expansion of the Montreal Art Institute and the innovative technologies that McGill deployed to ensure the success of this project. So yeah, a quick introduction about our company for those of you who don't know us. We are a general contractor and a construction management firm founded in Montreal in 1953 by Louis McGill, an engineer immigrated in Canada from Hungary. We have had and still having an important role in the development of several projects in the city of Montreal in Quebec. As you can appreciate in this picture of downtown Montreal, in which our realizations have been highlighted. And over the decades, we've been expanding our operations, and we are now present in several regions of Canada with offices in Toronto, London, Quebec City, and Vancouver. We recently expanded further and opened an office in Dubai to better serve our project outside of Canada. We have a vast expertise and a very diverse portfolio of projects, which include a multitude of high-rise towers, but also major institutional projects such as sports centers, stadiums, schools, hospitals, museums, public transportation projects, and industrial buildings. And we work on lump sum contracts, CCDC 5 construction management contracts, design build, EPCM. It is at the same time the most complicated and interesting aspect of working for a company like McGill, since every project is truly special and must be managed with a unique approach. So let's jump now into the presentation and start with explaining a bit more about this project. Like I said, today I'm presenting the redevelopment of the Montreal Art Institute, located in the neighborhood of Rosemont-la-Petite-Patrie, in the eastern part of the island of Montreal. The institute was founded in 1954 in the Maisonneuve Hospital. In 1966, the building on the current site on Bélanger Street was inaugurated, and eventually over the years, several major expansions have taken place, the most important of which were in 1976 and 1995, until the most recent project, which is currently under completion. The project includes the construction of two new blocks and an underground parking where a surface parking used to be. And moreover, the partial demolition and redevelopment of the north block, as well as some minor redevelopment in the existing remaining block. And yeah, this has been the winner in the construction management category for the 2021 Cannes BIM Innovation Spotlight Award. And in this presentation, I show you some of the innovative solutions that led to this success. It is worth to mention that we already won the Innovation Spotlight Award in the construction management category in 2020 for our project at the Trudeau Montreal Airport. So for us, this has been a well-welcomed reconfirmation in the most important category for a construction management firm. So the client designed McGill to be the construction manager during the pre-construction phase, to sit along the design team, bringing our expertise to the table. This project had innovative premises from the start, since it had been selected to be one of those using BIM and integrated design process during the design and pre-construction phase. And moreover, a laser scan LiDAR of the existing structure has been completed to allow for an high-quality model of the existing hospital. McGill was able to obtain the 3D models from the design team since the beginning, including any relevant update throughout the whole project. And despite the innovative approach of the design phase, the project still presented several risks for us, of which the most critical for McGill were a tight, fast track schedule, high complexity of the mechanical systems, which were coupled with the superior quality standards and very narrow tolerances. The demolition of the existing block and the connection to the existing building also represented a significant complication, especially given that the existing hospital continued to operate throughout the construction. And finally, and despite McGill having had already some experience with the BIM projects at the time, the BIM contract deliverables were still a relative newcomer for us, with all the unknowns that this entails. And more in details, these deliverables were the contractual deliverables required the use of BIM to coordinate the main mechanical systems, as well as the delivery of the as-built 3D models at the end of the project. So given these risks, McGill took the initiative to use several cutting-edge technologies going beyond the minimum requirements to ensure the success of the project. Let's begin let's begin with the project general setup. In fact, we made sure that our team had all the necessary tools and equipment to help them performing in their daily tasks, starting with a collaborative and mobile project management platform, what we call the common data environment, acting as a central hub for any other applications and software. And this platform has been made accessible with different levels of permission to all the project participants, including the client, the design team, the trades, suppliers. This ensured a single source of information and an enhanced collaboration and communication environment. Also, at McGill, we have always valued mobility. Mobility as a way to empower our employees, and all members of our site team have been equipped with the tablet device that allowed access to the relevant information from anywhere. We also encourage our subcontractors to equip themselves with mobile devices. And consequently, when considering the adoption of any new platform at McGill, the ability of the platform to be properly accessible from a mobile device has always been an important aspect to account for. The proper integration between a project management platform and mobile devices allowed the adoption of several innovative practices. For example, at the beginning of the process, we recreated the rooms and level structure of the project within the platform. Each location has been automatically associated with the QR code that can be printed out and pasted at the corresponding locations in the construction site. And this way, each information, document, picture, or element can be associated with the specific location and added in or retrieved from the platform through the use of QR codes. So every user is but scanned away from all the information relevant to the location they are physically in. Moreover, the project office has been equipped with the two large touch screens permanently connected to the CDE platform and thus to the most updated information, but also allowing access to several innovative software during, for example, coordination meetings. Obviously, these screens also help to greatly reduce the printing bill for paper plans, which on project of this size can easily sum up to some tenth of thousands of dollars. So overall, in addition to reduce project risk and increase communication, this approach has helped us to keep under control the need of manpower within the project team. And the human resources usually represents most of the cost in our general conditions for a general contractor. So now let's take a closer look at some of the solutions McGill adopted. For starting, in order to ensure close and successful 3D coordination, our team adopted a proactive and structured approach, which consists in several steps. And the actual clash detection was simply the last step of the process. Instead, virtual visits of the model have strongly been encouraged to avoid a passive participation in the process from the coordinators, who otherwise have, in our experience, the tendency to simply wait for the clash detection results. And without a proper pre-coordination, these results might include hundreds of clashes and quickly become unmanageable. So the coordination has carefully been set by sectors and levels and organized in a coordination schedule that has not been a simple anticipation of the construction schedule, but it tried to take into account through the feedback of trades and the suppliers. It tried to take into account several other factors like approval delays, production, manufacturing lines, delivery, installation of complex systems. So this allowed for a better prioritization of some issues over others, which otherwise might have slipped through the cracks because they were way down the line. So the approach is very important, but the tool can also greatly help to achieve a successful coordination and to efficiently share the 3D models between the parties and manage the coordination. McGill has once again chosen a platform, cloud, mobile, collaborative, and of course integrated with the main project hub. And of course, these platforms are truly a must-have for large and complex projects. And here is the first real extra mile that the team has put in place. In fact, the BIM collaboration platform adopted by McGill also allows a plug-and-play virtual reality. Therefore, plug-and-play, so without the need to convert, export, prepare the 3D models for such an application. This has allowed for a relatively quick adoption in several of the most complex coordination phases and sectors, such as certain mechanical rooms that do not exclusively have hard clashes, but often soft clashes, which are trickier to detect. A second unsolicited extra mile that the team did to ensure the success of the project was the in-house modeling of certain components and mechanical systems that were not included in the original BIM contract requirements, such as the ceiling mounted mechanical equipment in the rooms. This allowed us to better coordinate the whole project and also to avoid surprise clashes at the construction step. And this will also serve as a lesson in the future to carefully evaluate which disciplines to include in the contractual BIM deliverables. And outside of the contractually mandated BIM uses, we heavily leverage the 3D models to create a simulation of the global construction schedule. As you can see from this clip, it's not a nice, sexy video like those we often find online, and that's because it has not been prepared for publicity, but for the internal reviewing process. So for the team eyes only. The strategy was to start with a global for the simulation without going too much into the details. and then proceed iteratively with a series of review meetings to then maybe focus on certain portions of the calendar or some certain sectors that might present some potential for improvement, acceleration, or risk reduction. For example, here, the 4D simulation of the concrete structures and demolition sequences of the North Block have been detailed for a better analysis with the project manager, the superintendent, and all the trades involved. One of these meetings is shown in this picture. The main target was to better visualize the construction of the project to bridge the gap between the design and execution phase, ultimately to reduce risks and contingencies for us and for our client. And as a result of this analysis and in accord with the trades, the demolition and concreting sequence have been modified, and the results can be seen here with the new sequence on the left. And in fact, while the two simulations arrive at the final result more or less at the same time, the new sequence allowed us to accelerate the exterior works so that we've been able to close the envelope almost a month in advance with important savings on temporary heating, which are costly expenses that come straight out from our general conditions. So this optimization produced a direct and a measurable saving for McGill. And as we dug more and more into details, these simulations become less and less beautiful and more functional. For some mechanical rooms, we reviewed the sequences of mechanical systems installation in collaborations with the trades and the suppliers involved. And these simulations were prepared for the weekly coordination meetings to improve the collaboration and communication between all the parties. The final simulation was then transmitted through Simple's PDF reports, of which we see here the final assembly, to ensure that the information was as clear as possible. Then technology came to our head when the delivery of several large mechanical equipment, which are shown in red in this picture and are located in the main mechanical room, was delayed due to the supply chain interruption because of the COVID pandemic. These issues risk to delay the rest of the mechanical work in this room, which was on the critical path of the project. We then proceeded to analyze all possible routes of delivery and installation for the equipment in the room to find the one with the least impact on upcoming works. And once an agreement on the least impacting route was reached with the other parties, we performed a dynamic clash detection to highlight all the remaining installations that would have interfered with this path. So once this was determined, we were able to proceed with the rest of the work, knowing that the mechanical installations conflicting with the future delivery of the equipment would have been installed last, but avoiding the delay of the critical path. And the team estimates that almost a couple of weeks were saved this way. Another major risk for the project has been the existing structures. As mentioned, the hospital had been laser scanned and remodeled during the design phase. However, this only gave partial and incomplete information since many structures remain hidden until the beginning of the construction operations. This was the case for the existing foundations that became visible at the end of the excavation phase for the new block in the parking lot. But the systematic use of our LiDAR laser scanning device led to a quick detection of a difference in elevation between the design model and the actual site conditions. So all the relevant information has been shared with the design team for a quicker solution before this could cause any further holdup. The same approach has been adopted for the existing mechanical installations. Once again, as soon as possible, meaning as soon as the ceilings and partitions were demolished, our team did a LiDAR laser scan, which has then been integrated into the federated model for the validation of the coordination that has previously been done. We can see here some examples of potential issues that were detected early on in the process. Too often in the past, we properly completed the 3 coordination to eventually find out that the execution didn't quite follow, or the existing conditions weren't properly represented in the 3D model, then causing issues on site and undermining the trust of the stakeholders in the whole BIM process. But thanks to the use of our LiDAR device, McGill helped once again to bridge this gap between coordination and execution. Another risk that had to be managed has been the high standards of quality expected, coupled with very tight tolerances and very complex systems, typical for an hospital project. So during the execution of the new concrete structure, we widely used our LiDAR device to check the flatness and levelness of the new slabs. Our reports allowed us to quickly establish the areas out of tolerances to be fixed, and to communicate efficiently and clearly with the trades involved. It wasn't only a matter of tolerances for the finishes, but also for the door frames. So the new block had to connect with the existing hospital, which, as you may recall, had been built between the 50s and the 70s. And back in those years, ceilings were lower and mechanical spaces in the ceilings were tighter. And if you wanted the corridors in the new block to be built following modern standard, it would have been necessary to have transitions between corridors of different sizes, while the client understandably wanted to avoid any steps or ramps or difference in elevation. So this explains the extra complexity for the mechanical coordination in the ceilings of the new block that had to accommodate modern mechanical systems in an old-sized space. And also, back to the door frames, in order to reduce the impression of a low ceiling, the height of the door in the new block has been maximized, leaving an almost inexistent gap between the future steel frames and the finished ceilings. So this was an important risk during execution, directly linked to the levels of the concrete slabs, which were carefully checked and corrected as we proceed. The LiDAR surveys were also carried out as the work progressed to check the compliance with the coordinated 3D models developed for execution. Because again, BIM coordination is useless if the construction teams do not communicate effectively to the coordination team every last minute modifications and changes in the field. The team also used the parametric aspect of the BIM models to improve the tracking of work progress. For example, we can see here a parameter-based search set for a quick verification of a specific parameter, which was filled by the supplier and informs about the status of the item. So if it was under fabrication, fabricated, delivered, installed, etc. And being the point clouds federated with the 3D models in our collaborative platform, the information could be quickly cross-checked and updated if required. For example, this element status need to be updated to installed. Then in terms of verification and monitoring of the works, McGill made extensive use of 360 panoramic cameras, which allowed to document the job in a structured and proper way. This tool allowed us to make virtual visits automatically file per location and date. Not only that, but this system is also well integrated with our BIM models, reducing the need for our team to physically walk the site to ensure quality and BIM compliance. This way, the verification process has been made even faster and more efficient. Moreover, for the project milestones, for example, prior to close-up partitions or ceilings or deliveries of specific sectors, higher quality 360 cameras were used. And all these tools, coupled with the virtual reality and CDE platforms, greatly helped the project to get through the COVID crisis without any major issue, reducing for everyone except for the workers that need to be physically present on site. Nowadays, these technologies are helping to reduce traveling costs for us, our trades, clients, and their consultants on all our projects. Nevertheless, the presence on site can be reduced, but never totally eliminated. I already mentioned the deployment of tablets, devices connected to our collaboration platforms. And here we see them at work, allowing the full access to 3D models, their parameters, and all necessary information during the inspection walks in the field. Finally, part of the mission of our department also includes R&D, and the team had some fun testing out on this project some advanced tool that bring the augmented reality closer to an actual application in the field. And I remember testing myself a first version of the HoloLens in 2016, and only a few years later, I've been fairly impressed with the evolution and progress of this device that hopefully would bring us one step closer to a flawless BIM coordination and the creation of an actual digital twin of the project. Which brings me to the conclusions that we drew on the adoption of BIM-VDC for this project. So the first thing I'd like to notice is that nowadays there is a lot of noise about innovation in the industry. We hear a lot of buzzwords like off-site fabrication, robotization, big data, 3D printing, 6D, 7D, parametric design, artificial intelligence, and all of this is of course very interesting. However, these kind of innovations remain, for the most part, out of the control of a general contractor like McGill. In fact, and while we can act as an advisor in some situation, is usually the client, is investors, and is consultants that have the main power to steer the adoption of most of these technologies. Meanwhile, for us, the bigger risks on a construction project are related to unforeseen events that occur during the execution phase, events that by the very nature of our industry can have a terrible cascade effect. And to better understand this, take a look at this study on cost overruns for roughly 1,500 North American major construction projects. That's a graphic with an asymmetric thick-tail distribution leaning towards the right, where we have projects that incurred in cost overruns. And this means that although in most of the cases the project was finished within budget, there are more chances for a project to go worse than for it to go better. And not only that, when it goes bad, it has high chances to become catastrophic because of the well-known cascading effect. And in our industry, with tens of millions of dollars bound up in projects that last several years, a single highly unsuccessful project might mean for a company to go bankrupt. So consequently, our innovation efforts must focus on increase the ability to predict any contingencies and reduce the risk of these disastrous cascading effects on the project budget and schedule. And we often hear that we should follow the example of the manufacturing sector. But this is not an option for us. In the manufacturing sector, you develop a prototype and then you mass produce a product. For us, there is no product to be put into production, since every new project is a prototype. So a new prototype is built every single time. And even the project that looks very similar, like high-rise condo towers, are not that similar. The location change, the ground, the consultants, the trades and the suppliers, the management team, the legislation. And this project lasts for years, which makes very hard and long to test and implement innovative solutions. So the production of most of standard components assembled in a building is already industrialized. Anything that you can prefabricate as a standard actually is already has already been industrialized. But still, the construction productivity overall hadn't changed much in the last decades. It's not as the industry doesn't want to innovate; it's that it's not as simple as it sounds. So at McGill, instead, we try to fill as much as possible the gap between design and execution, between the project and the prototype, to reduce the unforeseen, to lower the risks. Ultimately, we need to simulate the construction process as much as possible to build digitally before physically. That's a low-hanging fruit, relatively speaking, and it's upstream that we are able to do that during the pre-construction phase, in our case. And that's where we decided to invest, because that's where we can have a quicker ROI. It's with the 3D coordination, the 4D simulations, and the logistic 3D planning, et cetera, et cetera. And it is worth noticing that our trades, suppliers, and consultants play a big role in the success of our projects. However, we do not have much control over their innovation efforts and the technology adoption. Do not take me wrong here. We deal with excellent companies and firms without which our project could not be successful. And we obviously hope that the projects like the Montreal Art Institute will keep inspiring them to continue investing and innovating for their benefits, but also for our benefits. Not to forget that the most benefit of implementing BIM, globally speaking, remains in the long term during the operation and asset management, with the delivery of a full 7D asset information model, an actual digital twin. So last but not least, we hope that the industry, we hope that the clients will also be inspired to continue investing and innovating, to keep pushing innovation forward for the whole industry. And on that, my presentation is over. Thanks everybody for your time. I hope you found this project interesting. And if anybody has some question, I think there will now be a Q&A session. Otherwise, you can contact me on LinkedIn or at my email, which is shown on the screen.
Yeah, thank you so much. Excellent presentation. Lots of innovation there. We do have some questions that have come in. I just want to remind the audience, of course, if you want to learn more about any particular part of that presentation, get your questions in, and I'll try to fit them in with the time that we have left here. The first thing I wanted to ask was, what does your team look like at McGill? I mean, from my experience, the hardest part with deploying new technologies, driving innovation in a big firm, is the cultural piece, like getting the company on board to accept these changes, to be willing to change their best practices, to test new technologies. Maybe you can kind of describe a little bit what your team looks like, how you've deployed it, who's on the job site, and maybe a little bit of like the executive sponsorship piece, and how your sort of executive team have helped to support this initiative.
So yeah, we try to have a two mission here. We try to keep the team to its minimum. We don't want to have tenth of a BIM manager at McGill. We want to have a core team of champions user, people that mostly have a passion about this, that are good to teach people, that are good to go the extra mile, to explore, to innovate, because we want to bring the rest of the company up to speed, instead of doing the BIM for them. So we don't want to be seen as there is BIM deliverables on this project. We will have a BIM manager that will take care of that. Now, the idea is to change the project coordinator and project manager and superintendent role to bring them to use these tools and not add them more tasks, but replace the old task with new one and get them to use more optimized tools. So we have that mission. We're not that many for this reason, because we try to have a project coordinator, a BIM user on any project. Then we have the project support, of course, for the most advanced application like 4D, 5D analysis, quantity takeoff, etc. So we have a core team here at the McGill office that is already available to help out on specific usage, like the LiDAR laser scan as well. That's a very specific application that cannot be learned by anybody. So we have an expert. The expertise of the LiDAR laser scan is here at within the BIM department.
So you're a big company. You've got like a central group of experts, like the LiDAR group and other kind of supporting roles. And then you've got like a VDC coordinator assigned to the project that lives on the project job site that you support and train and help.
Depending by the type of the project, we now use BIM at different level. I can confidently say on 100% of the project. Every project at McGill, at least here in Quebec, and we're expanding the BIM usage in Ontario and BC as well. But at least in Quebec, all the project has some kind of involvement from us at different level. Then we have the BIM contractually mandated project, those with BIM deliverables. So for those, we have a specific BIM manager budget in our general conditions, and I want those BIM coordinator or BIM manager to really be part of the project team. So they moved on site, they're in the field, they work from there, and they became part of the team.
Were you involved with championing this whole initiative within the business, and how did you get the executives, the sponsorship, the sponsor this initiative within the business to evolve and change and use this new technology? Is it just the culture of your company is very open and they want to learn more and they're driving innovation, or did you have to kind of internally, convince people and get the operations managers and superintendents on board? And maybe can kind of describe that, because there's a lot of companies out there that are still going through this internal change management struggle.
So we've been lucky because the first input came directly from the top. In our case, our old CEO. Well, back in the day, in 2016, we lost a couple of important contracts to the competitors because we were in BIM. So I was a project coordinator that apparently showed some technology skills. I was pretty good with Excel, I'd say, and yeah, the CEO asked me if I was interested into starting this new department. So we dealt with initially with the consultants for the first year until we were able to walk on our feet. So since the first input came from the very top of the pyramid, that definitely helped. After eventually, it has been very important to show to focus on some concrete results. So yeah, you want to plan ahead for the long run on developing some very complicated BIM-VDC applications, but you need to quickly show some actual advantage to the estimation team, to the construction team, to the CEOs, to the project manager. Otherwise, they all start with the idea of it's a nice toy. It's if the client is gonna pay for it, then it will be fine. So the first mission was to show that no, it's not simply about the client paying for it. There are usage of BIM that, regardless of the client requiring or not, bring us some direct advantage, some direct savings. So we try to focus on that. Some basic for this simulation, and those coordination meetings, those bring the superintendent and the project manager in the room and show him how his schedule will actually work out, and he was actually able to see something that he missed because he didn't have this visualization or the 3D coordination. Of course, 3D site logistic was one of the first application we used. So just simply modeling excavation and point of access, exit, deliveries in the
Right
site
on.
building.
Yeah.
You get the superintendent, you get the interest from the superintendent, the safety agent, the coordinators and stuff.
How have you found, since you've taken on this responsibility, how have you found the relationships with the architects and engineers and their maturity with delivering models that you can actually plug and play into your process to actually build with? Are you recreating their work because the models they create are inadequate or not structured for your use? Or are you finding that the market can deliver a data set that you can utilize for your purposes?
So we've seen them all. We work. We don't work always the same because, like I mentioned, we deal with the old kind of contract at McGill. So of course, when we deal with the design build, we get to choose our consultants and architect. But in all the other scenarios, we cannot. And most of the architectural firms and engineering firms already adopted BIM at pretty wide extenses, so it's not a problem anymore. Depending by the type of contract, that there might be some resistance to share the model. Mostly if there isn't any BIM execution plan in place. So we have a whaler firms and we try to reassure them the most we can that we're aware that their 3D model is only shared for information only, and the 2D drawings, PDF signed and stamp will always be will always contain the true information. We are able to deal with them. So that normally works. We had sometimes the needs to remodel a part of projects. It's happening more and more, but it's mostly from the trade sites. So we get a project, we want a model for coordination and execution. Trade, specialty contractor, mostly those involved with prefabrication, they're more and more involved in the BIM process, but there are still companies that represent a big effort for them to go there. So in that scenario,
how do you
we
manage
prefer
that from a risk perspective? I mean, in an ideal scenario, your trade would be producing a model for their purposes that's going to be used for fabrication, and you're just pulling it in and integrating it, checking it. In a scenario where your suppliers don't have that level of sophistication yet, but you need their systems represented in your model to make sure they're going to fit and work. Are you providing services to your suppliers to coordinate their work, or are you sort of taking their shop drawings and model them quickly to check? And how do you manage the transfer of risk there? Because you don't want to take responsibility for their issues ultimately, right?
Yeah, of course. Ideally, I would like to tell the procurement team to give the contract to a trade which with the experience in BIM, but that's not an option today. We have discipline. We having our time having one or two bidder, so we cannot afford to lose a player because he doesn't want to go BIM. So instead, we take out the contract obligation, and we take care of the modeling. Normally using third-party companies. We're going for a 2D to 3D drawings. We don't take away
third-party company, or does the supplier contract a third-party company?
No, we contract the third party and we control them, but it's a 2D to 3D mandate. Okay, we're not taking away their coordination responsibilities, or they're still in charge of producing 2D coordinated drawings. They're required to participating in the 3D coordination process. So they're invited into the collaboration platform. They sit at the table during the coordination meeting. They take care of the clashes and issues assigned to them, but they don't work in 3D. They adapt their 2D drawings. Then we send them to the company. Those companies are very quick. If the 2D drawings are clear and well done, they overnight the work, they send it back, and we're able to
it's difficult. Sometimes you can get a bottleneck there with the turnaround. So ideally your suppliers are at that level. And then how do you, do you put a requirement in the contract that the subtrades have to install as per the model that's been agreed upon, and are there consequences if they don't?
Not all the contracts. Yeah, the most advanced contract, the most complicated project, but mostly the those we do with the institutional projects, design build, lump sum. If lump sum, it's not possible because we cannot impose any contract specification that it's not already there. But on a design build, yeah, definitely there is a clause telling not only that they have to do a 3D modeling, also that the 2D drawings must be extracted from the 3D modeling without any additional or changement in the information, and the work has to be executed as coordinated. And then, like I show, we try to use those tools to make sure that the works are compliant to the 3D model.
There's been a handful of questions that came in regarding your sort of technology stack and the different products you're using. Maybe you can give a quick snapshot of the different systems that you're utilizing. Obviously, a lot of Revit files and whatnot. Are you using Navisworks, Revisto? How do you manage your common data environment? What do you use for LiDAR collection?
Well, I try not to mention specific vendors in the presentation, but of course, it was clear some products that we were using. So the main project management platform is Procore, which sits really at the center of all operation from a project management standpoint, site management, financial management, really everything integrated with Procore for us. Then there was Revitsto as a BIM platform that little by little is replacing Navisworks with being more collaborative and advanced for clash detection and coordination. We're still using Navisworks for those dynamic clash tests we did when you need to simulate the moving parts. For this simulation, for this project, we used Synchro 4D. We're now trying out other softwares for the 4D part, but we were still with Synchro back in the day. For the point cloud management, we now own a Leica RTC 360 using all the Cyclone software to playing puzzle with the LiDAR point cloud.
So is it RTC? The RTC, right? Not the little BLK one.
No. The RTC is the perfect for us because
great device.
At McGill, we mostly work on architectural work. We don't do much infrastructure or civil, so we don't need to go look for far away points. So it's light, it's fast, it's easy to work with. It's a one button, and you go. But then we use this software called Bloom Cloud Engine, which is a Canadian software to then perform some analysis.
Great product, And then were you using OpenSpace for 360, or what was the 360 photography product?
It was OpenSpace and Matterport. When I said that for those milestones, we used an higher quality camera, that was Matterport. Simply OpenSpace, we're not even in charge of that. That's the project team. So every project team at McGill, they have a camera, and instead of taking pictures with their iPhone, they just walk the site with this 360 camera strapped on their hard hat.
Yeah, right on.
While the Matterport, you need to put it on a tripod and get to the site and use it. So we try to limit the use to the milestones only.
Are you using for common data environment, are you following any kind of specifications? Are you defining, obviously have a BIM execution plan where you define LOD. Maybe you can kind of talk about how if you're using specs on that, or is it internal, or how do you manage that whole process of establishing those requirements and managing
of course.
data?
We have our own BIM Execution Plan standard developed in-house. We're using uniformat for the LOD and master format for the contract award. That is the standard LOD 100, 200, 300, but it's like a guidelines, because then it's clearly stated in the BIM Execution Plan that that's the minimum requirements. Then for specific mechanical room or specific portion of the building, we might ask for more. And we also specify the LOI, the level of information. There isn't really a standard globally accepted for the LOI, so we developed by class of use information to better estimate, information to better manage coordination, information to better manage a 4D until the information to produce an asset information model. And we also specify the LOA, level of accuracy. But then again, that's depend by the client. So if the client doesn't have any BIM execution plan on any requirements, we go with ours. But when you work with big players, the SQI, the airport in Montreal, the Montreal town, Quebec city, they all have their own standards we have to comply with.
Yeah, right on. Another quick question about the LiDAR. You did some as-built scanning here. You captured the existing mechanical piping and whatnot. Are you positioning that as like a value-added service on a construction management project, or are you kind of baking that into your overall construction management fee? Like, how have you structured that? Because it is, those devices are $100,000, and you got a devoted team. How do you position that with a client?
We have a budget which account for those applications. But the same answer again, depending by the project and depending by the contract. If there is an application, potential use case for the LiDAR to better fix a situation that didn't came from us, we normally have a change order open, and we collect the expensive, the time used, the laser scan, and ultimately it's better for the client because instead of going with the surveyor, it's way cheaper to keep this with the construction manager than going award a third contract to a surveyor company or whatever. And most of the time keep in mind that the laser scan, you don't replace a total station with that. Okay, it's not the same thing. And those are, you need to play with it a lot because before getting the grasp on the actual technology and how you can actually use it. So of course, the laser scan, the vendor is going to tell you that it will take points 300 meters away, but we know that further than 30, 45 meters, you're starting losing trust in the accuracy. So you need to know what you're getting into, and don't, in order to avoid to create false expectation by the project teams. Sometimes my answer to them is, you don't need a laser scan, you need the total station.
Right tool for the right job. Well, I'm being told here I got to wrap up. We're kind of coming into the end of our time, but there's still lots of questions coming through. I would encourage everyone to reach out to you directly. You can share your email, or you can direct them to LinkedIn. It's up to you.
It was in the last slide. I put my email, or you can look for my name on LinkedIn. I don't think there are many Federico Pensa on LinkedIn.
Thank you so much for the presentation. It was great. Thank you so much for being our first project story. I thought it was very good. And hopefully you can come back and tell more stories about future projects. And just want to thank our audience for attending and the questions. And of course, tune in for our next events. We've got a number of events coming up. February 24th, we're putting together a really amazing construction technology focused event that's going to be focused on actually putting work in place on the job site. So robotics and other things that augment human labor on the job site, and focusing on that sort of connection between these digital workflows and automation, and actually assembly on the construction site. So a really amazing show we're putting together there with a number of amazing presentations. So that's February 24th. March 3rd, we have the Innovation Spotlight release. We're going to have an event related to that. So every year, as you know, we publish our Innovation Spotlight. We feature some of our award winners, including McGill. So you'll be in that book. That release event is going to be on March 3rd. Other housekeeping items, obviously want to thank all of our sponsors, a number of sponsors that make this possible, including SoftDrive. Go check out their website at softdrive.co. And of course, subscribe to our YouTube channel. This is where this content's going to go. That's where we're publishing everything. We'd love for you to go over there and subscribe right now if you don't mind. And tell a friend, if this is interesting to you, if there's something here that you've learned, you want to share with one of your colleagues, please share this content with everyone. That's our objective here, to share information. And thanks so much again to McGill for sharing information here. Really amazing work, and we appreciate it.
Thank you. Thank you, Thomas.
Okay. Thank you, everyone. And we'll talk soon.